Okay, this is multiple choice section 2A, so this is all about basically just finding the derivative. There are a lot of questions in here. I would probably do most of them just so that you are remembering all the tricks and all the kind of neurotic things that come along with derivatives. So for number 16, this is implicit differentiation. So remember when you're taking the derivative in terms of your y guys, this guy right here, make sure that you know we're going to take it as 2y, but then you also need to take the derivative of y as well. So this guy is going to break down. This is your product rule. I made 2 a constant multiplier, kick that guy out, and did the product rule with just x and y. Everything kind of simplifies out, multiply the 2 through. The idea is you want to get that y prime by himself, factor that guy out, and we have that hanging out here. Your job is to find what that derivative is when x equals 1. Well, in order to do that, you know x is 1. You need to find the corresponding y value. So just kind of the algebra that works you through there. So really, x is 1, y is negative 1, plug and chug. Ends up being undefined. You have 0 in the denominator hanging out. Number 17, an equation for the tangent to the graph of that's inverse sine of x over 2. At the origin, so you're doing x is equal to 0. You need to find the corresponding y value, just like we did in the last problem, so that the corresponding y value is also going to be 0. This is the actual derivative part. Oops. So you have your inverse sine property, and then multiply by, this is an example of the chain rule, so you got to do x over 2, the derivative is 1/2. This is all algebra hanging out over here, so 1/2 is from your chain rule, that's x squared over 4. I combined it and made it into one fraction on the inside, so 4 minus x squared over 4. Gave a radical to the top and to the bottom, so this would have been radical 4 would be the in-between step, which gave me 2. Those 2's cancel, so you end up with actually something quite nice, this guy. Plug in your 0, so your slope is going to be 1/2. You're writing the equation. This is an older test. I think this is from 69 or 73. But basically, they did a lot more stuff in standard form back then, so you're typically going to have point slope form or slope intercept form as your answers. So if you got there, great. The idea with standard form is you can't have your coefficients have to be integers. So x and y are on the same side, kick those guys to the same side, and then x should lead and he should not be negative. But I trust that you guys should probably, based on your choices, kind of get where you needed to go. 18, this is just take the derivative. So this is natural log of something, so 1 over that something. Chain rule times e to the 2x, and then times 2, chain rule again. You can kind of see where it simplifies down. From there, basically these 2 guys cancel, and so you're left with just 2. This is a lovely problem, really stretching your brain on this one. Sine of x equals e to the y. They want to know what is the derivative in terms of x. Well, the first thing that you kind of should notice is it's not solved for y. So the very first thing you do is you solve for y. This is an exponential function. The way that you solve exponential functions is you put them into log form. So log-based, we're used to having it in this. I know the side shouldn't really totally matter, but sometimes when you're doing this kind of crap, it's nice just to have what your brain's familiar with. So you're going to do log base e of sine of x equals y, which is where natural log sine of x equals y comes from. So now what you're looking at is basically the derivative of natural log, 1 over the stuff times the derivative of the inside stuff. This is cosine over sine, which is the same as cotangent, trig identity. This was a lovely, lovely problem. So what I did is there's your y, your u, and your v. So we're going to have to take the derivative of y with respect to u with respect to v. Okay, because we have all those kind of like inner functions going on. So derivative of u times the derivative of v times the derivative of your y, derivative of your u, derivative of your v. You have x being equal to 0. So what I had to do to get 0 here was I evaluated my u, and this is 1 over v. Okay, so you end up with 0. And then this is evaluated again at 0, so plugging and chugging again. So it was that. And then 1 over e and kind of multiplying through. Not a pretty problem. I tried, and I had the same answer, but it was just ugly. And it took up a full page, so I just did it this way. It was a little bit simpler. You could definitely substitute all that in. Just, it gets a little messy. I'm not going to lie. You're guaranteed to see something in this way, shape, or form on your AP exam. So this is the difference quotient you have as x is approaching 0. So that's the big thing that you're looking for. H approaching 0. This is just a fancy way of saying what is the derivative. So if I kind of ignore the h for a second, this 1/2, remember, this is, your function is this. So your difference quotient is this. So this is saying at x equals 1/2, it wants you to take the derivative. Well, this would have been 8. Think of that as being x. This is really 8x to the 8th. So that would be 64th x to the 7th. Put in your 1/2. This is 64 times 1 over 2 to the 7th is 128, which is where you get your 1/2. Slope of the tangent line to the graph. So this is take the derivative, so 1 over x squared, chain rule times 2x, simplifies to 2 over x, which is 2 over e squared. This is just take the derivatives. The derivative of x is 1, derivative of sine is cosine. Hody hi, Heidi ho. Just make sure you put everything in kind of its proper place. So we're going to end up having kind of a nice function, but here's your ho, d high minus high d ho over ho squared, plug and chug, ends up being, I think I had 2/4, and then it just would simplify down into 1/2. Chain rule, and chain rule again. So your outer is the cosine being squared, and then your first inner is cosine, and your final inner is 3x. So kick out your power. Your first inner is cosine, so multiply by negative sine of x, that's its derivative. Your next inner is 3x times 3, and just simplify that bad boy down. That should have a 3x there as well. Another inverse trig. Now we've had 2 inverse trigs. They both have been sine. Sine and tangent typically are their favorite ones to kind of throw at you. I rewrote it. So this is going to give you, this is your very basic no chain rule. This is putting everything in. So this would have been 2x going in there, squaring that quantity, multiplied by the derivative of the inside stuff, which was multiplied by 2. So that 2 up there to kind of save some room. This was not the easiest one to kind of see what was going on. This is the difference quotient. That's your hint. That 1 over h, throw that h in the bottom. It's the same way as saying that. This is the quotient rule for logs. So this is natural log of 2 plus h minus the natural log of 2. So here we are. We're going to look at this in the same way that we looked at that a few problems ago. So this is really the derivative. Think of that as being x. So this is really the derivative of the natural log of x at x equals 2. So it's going to be 1 over x. And then since it's at x equals 2, you put in your 2, 1/2. This is expecting you to kind of apply, and what I did is it's saying, I'm not going to tell you how many times I'm going to take the derivative, but there's a definite pattern when it comes to e to the something, and that's because e to the something, the derivative of it, is e to the something times the derivative of that something. So I just kind of plugged and chugged until I saw my pattern and picked the one that it matched. Oh, this one was lovely. I am willing to bet most of us got here nicely. That should have an equals 1. That probably wasn't the terrible part. The next step that I did, this is distributive property. So secant squared of that times xy, secant squared of xy times y, so this breaks down into this. Now you have to isolate your y prime, who's only hanging out there, so 1 subtract that stuff, divided by that stuff. And this is all algebra from here on out, which is why it became quite lovely. So I broke this into 2 separate fractions, so 1 over that stuff, negative y, or I kept the subtract y over that stuff. Now, what I did is that secant squared moved to the top to get cosine squared, and that still had a denominator of x, so it became cosine squared of xy over x. Secants canceled over here, and that went down into y minus x, and then recreated one fraction. The reason I chose to do that is because my answer was leaning more towards one of the cosines than it was having the secant. So that's kind of what I was trying to. Typically, I probably wouldn't have worried too much. I would have let us stop here. But when we're looking for something on the AP exam, look at your choices and go from there and see how far you have to go with some of that simplification. This is on your semester exam. It was your very first question. Fourth derivative, so keep taking that derivative. Be careful with your multiplication. This is non-calculator active. This is a nice little quotient rule again. So Heidi ho, Hody hi. Hody hi, Heidi ho over ho squared. Simplifies down into that. 33, which is this guy right here. Nothing too crazy. Derivative is 1. No matter where you are on the derivative, it's always going to be equal to 1. It's a nice linear function, so its derivative is a constant. This guy, 34. Slope of the tangent line. They love some natural log on these derivatives. So 1 over, and I just wrote it as 0.5x. Multiplied by the derivative. I was glad I did because then I saw that those guys canceled. I had 1 over x. You were concerned when x was equal to 4. Boom, 1/4. Take the derivative. So you got to know your derivatives basically. Just don't forget your chain rule. It's kind of hanging out there, and that's where that 2x came from. So this is one we don't see a lot, but this is the derivative when you have a base other than e. This is implicit differentiation again, so just make sure that you're paying attention that when you have a y hanging out, I better see a y prime. Get your other terms that don't have a y prime to the other side, factor out your y prime, and then divide by that remaining stuff. When you looked at your answer key, you didn't have this guy identical, but what I did notice is that I could take a negative out, and that's where that guy came from, therefore matching A. What you're looking for is you better have the same thing. I looked for when I had something in the same in the top, which happened in 2 places. And then I looked at the denominator and I saw that my denominator matched, and it came down to just needing to factor out a negative for it to work with A. E, nothing really matched. So just make sure that you, I guess you're just checking your work as you go. This was another doozy. We don't spend a lot of time on double angle identities. You spend 1 day in pre-cal on it. What I decided to do when I was looking at my answers, I decided that I needed to probably think about maybe rewriting the sine squared, because I wasn't seeing anything with sine and cosine kind of factored out. So this is my Pythagorean identity over here. So I took out sine squared, so I did 1 minus cosine squared, became -1 plus 2 cosine squared. I took the derivative. This is your derivative, so this is 2 and the negative went out front to create this guy. 2 cosine of x, sine of x, it's a double angle identity for a double angle for sine, and replaced it. 38, inverse tangent of cosines. This is an inverse with a chain rule. 1 over 1 plus cosine squared times that derivative. Just match them up. 39, another nice derivative. My first step is I rewrote it as negatives, took the derivative, and evaluated. E to the x, so this was one on your semester exam as well. I think it was number 18. So use the difference quotient, and then I put in my e, and just kind of look for which one matched. And this will be the last one that we talk about, but this is where you're talking about things changing from concavity. I would say concave up, concave up, concave down, probably concave down. So 1, 2, 3 places, 3 points of inflection. There's 4 different types of concavity, but 3 places where that concavity changes, and that's what you need for a point of inflection.